So, hello everyone. So, today we are going to start the new topic, that is on bioprocess economics in this module. So far what we are discussing, it was continuation of the last module, that was downstream processing, and in the last lecture we discussed about drying unit operation. So, there we discuss what is moisture content or humidity, then how drying process is done at maybe at atmospheric pressure or under vacuum or the freeze drying, and we discuss the mechanism of removal of moisture through evaporation or directly through sublimation in the case of freeze drying. Then we discuss simple drying kinetics. We assume the rate of drying is directly proportional to change in the moisture content minus dx upon dt, and if you integrate that you can get the drying time, and drying operation can be performed in both batch as well as in continuous mode, and accordingly we discuss what are the different setup of instrument which are typically used for drying unit operations. In addition, we discussed two moisture content, one was the critical moisture content and second was equilibrium moisture content. So, if you see the drying curve, so after the second falling period still there may be some moisture content may be there, that we are referring as the equilibrium moisture content, because beyond that the moisture cannot be removed. Now, going ahead for today's lecture, it is a kind of a new but very important topic, particularly for commercialization point of view. So, first we will see what is bioprocess economics. Then if you want to evaluate the economics, then what are those evaluation matrices, then what are different bioprocess economic models which help us to simulate and understand a particular bioprocess and its economic part. Then next topic we will discuss, because as we are discussing the economics, can we think of sustainable bioprocessing as well, because you cannot push too far to the economics. So, there should be balance between sustainability as well as the economics, and then we will see one case study for for insulin, that how one should proceed with bioprocess economic models, and further this understanding the economics part. So, this bioprocess economics, it studies the financial aspects of developing and commercializing biological production process or bioprocess. And what does it include? It include evaluating costs, revenues, profitability of the product. For example, it may be pharmaceuticals or the biofuel. So, it considers the cost, revenue as well as the profit analysis. So, if you see, this finance is not a domain of bioprocess. So, this particular topic integrates chemical engineering, biotechnology as well as financial principles to assess feasibility and sustainability. And why it is important? Because it helps in decision making. For example, if you want to go with new product, then this economic analysis will indicate whether you should go ahead or not. For example, if you want to buy a new, for existing setup you want to buy a new equipment, then you can assess whether it is worth buying that particular equipment or investing that money for that purpose. So, bioprocess economics guide research, investment, risk assessment, process optimization and policy decision in biotech industry, because everything is governed by the finance. And industry applications, so you can name any: healthcare, agriculture, energy, for sustainable and efficient production methods. So, everywhere you need to go for this economic analysis part. So, in the case of bioprocess economics, so basically what it study and analyze the cost, investment and economic feasibility associated with development and operation of a bioprocess. So, what are the components it considers? It considers the raw material, utility, labor, equipment, maintenance and regulatory compliances. And then based on that it determines the commercial feasibility of a bioprocess. It helps in then further decision making. In addition, it involves the process optimization, how to maximize the profitability and to ensure that this process is sustainable. Now, we can understand what is the importance of this topic. So, first is it analyzes the opportunity for cost reduction and process improvement, because if it is not feasible means you have to rework and with the different strategy to reduce the cost or improve the process. Then profit based manufacturing for biopharmaceuticals. It helps in the decision making in terms of process design or scaling up or even replacement of a existing or adding a new equipment. And it compares the different strategies for cost effectiveness. So, we can choose which is economically feasible, which one is environmentally feasible, and based on that it is suitable decision needs to be taken. Now, you can understand the objective of bioprocess economics. First is the capital investment should be confined to a minimum. Second, the raw material should be as cheap as possible and it should be utilized efficiently. Third is the highest yielding strain should be used. So, the yield should be relatively higher, and there should be a saving in the labor whenever possible. So, automation should be encouraged and process time should be short as much as possible, so that we can finish the process quickly, and downstream process should be simple as well as rapid, and one should keep the minimum number of unit operations. And further, as I told, we need to meet the regulatory requirement. So, whatever this effluents are generated, those effluents need to be treated and suitably either discharged or reused. So, idea is the effluent discharge should be kept to be minimum, and you can say the effluent generation should be minimized, and this heat and power, the energy should be efficiently utilized. Space requirement, it should be as much compact as possible, and all the above must comply with the safety guidelines and regulations. Now, what is the role of bioprocess economics? So, it play a continuing role at nearly every stage of a plant design project. Now, if you want to design, for example, a new project, so there are multiple stages. So, it start with inception, means you are getting the idea, you want to set a project or you want to produce a new metabolite, you want to adopt a new process. Then you have to go for preliminary evaluation of economics and market, what is the current scenario. Then you have to develop the data necessary for final design. Then you have to go for final economic evaluation. So, here you need to take decision, and once you say yes, then you have to go for this detailed engineering design, and once the design is done and approved, then you have to go for the procurement of, let us say, infrastructure, procurement of equipment. Then you have to go for its installation and erection, and then followed by you have to start. So, you have to go with the startup and trial runs, and finally, this is your target, you have to go for the production run. So, these are the multiple stages, and this all depends on the this economic analysis and final economic evaluation. So, ultimately if you see, it involves the estimation of capital investment, estimation of operating cost, analysis of profitability and sustainability assessment. So, here you can just see it start with inception and it reaches up to the production stages. So, inception, as we briefly discussed, so it may come from the suggestion from the sales department, it can be emergence of a competing product, it may originate from customer request, or it may be from the offshoot of the current process. And in addition, parallelly it may come from the research and development. Now, once it is there, the next step is preliminary evaluation. So, there you have to recover its cost and return. So, you have to see what is the profitability of this process, and then determine the potential market size and what will be the competitive price. And once it is done, then next step you have to development of data necessary for final design. Once it is approved, then it includes both market as well as the cost refinement, and now here it involves full market analysis and giving product sample to customers, and the objective here is to design the plant process flow sheet, determine the capital as well as operating cost, estimate process profit and payback period. So, how to calculate payback period we will be discussing in the next slide, and final economic analysis. Now, in the case of final economic analysis, this part involves comparing the estimated profitability for competing projects, analyze organizational strength, identify process area potential, and assessing anticipated growth direction for the future. And once it is there, then you have to go for engineering design. So, it provides information for construction of subsequent plant, and which includes equipment sizing, specification, piping configuration, final price quotations. It may it includes complete design, construction design, evaluation, drawing, plant layout agreement, and or any other information needed for actual plant construction. So, once the drawing is approved, then we go for the procurement. So, there you have to go for this purchase and receipt of land and equipment, and then you have to see how to manage construction, operation and utility installation part. Then finally, it goes for the construction and this erection of the plant equipment, machineries. Then you go for this startup. This includes break-in, trial of the plant, operator training, shutdown and safety procedures, and production. Then final phase of the plant, design product, and then it goes, and then the product goes to the market. So, here if we just see this, you can classify the whole idea into different levels. So, it starts with new product candidate, for example, then you go for its feasibility analysis, evaluation of product opportunity. Then next step is the development stage. So, there you are setting development objective and preparation of budget. Then next step is go to market entry and leading to the commercial product. So, if you just see, it is following a trapezoidal shape. It means there is a drastic reduction is number of product candidates moving from feasibility study to the commercialization. So, you just see at the research stage, the chance of commercialization is 1 to 3%, at development stage 10 to 25% and pilot plant scale it is 40 to 60%. So, in this way this process design proceeds, and you just see there are different level, and finally, only a few idea, few product, a few process are finally going for commercialization. In addition to that, there are certain regulatory requirement. So, we need to revisit and examine the economic assumptions throughout all the phases. So, there are various regulatory agencies, for example, Food and Drug Administration or Environmental Protection Agency. They are in US, similarly in India also they are, the Pollution Control Board are there. So, you need to have the consent and you need to design your process in such a way that you meet those specified norms. Now, what you need to meet? You need to meet the quality of your product, and in addition it is very important you also need to meet the guidelines for the waste generation and waste discharge. Now, as we know, particularly in the bioprocess, you can consider the fermentation section and product recovery section, or you can say upstream as well as the downstream processes. So, this is a generalized process flow sheet. If you just see, it start with laboratory inoculum, primary seed, secondary seed, then it is going to the fermenter. There you require water stream, air stream. In addition, you are going to add the media. So, you are adding media preparation, media sterilization, it is going to the bioreactor. So, upstream is up to here, then from here you are starting the downstream, and parallelly if you see in the downstream you got your product, but there is also the effluent generation that need to be suitably treated and discharged. Now, next comes how to proceed for the economic analysis. So, for any idea the following things should be done. First, prepare a detailed process flow sheet, then a specification of following items, for example, measure substrate, raw material, type of reaction, principal product and byproduct, which is the biological agent, agitation, aeration and process control requirement, and any special operations involved in upstream and downstream. So, there are three components for the cost analysis. So, one is a capital, production cost and materials and utility cost. So, capital cost it includes this bioreaction and product recovery equipment. Production cost, it may be salary, supplies, maintenance, taxes and depreciation. Material and utility, feedstock, nutrient, additives, packaging materials, electrical, steam and water requirements. So, typically in capital investment it has direct fixed capitals, working capital and startup and validation cost. So, fixed capital investment include the cost for equipment purchase, facility construction, utility setup for bioprocess infrastructure. Similarly, in the case of operating cost, it is also known as recurring cost. So, fixed cost or capital investment is a non-recurring and operating cost we refer as a recurring. So, such as it includes raw material, labor, laboratory, utility, maintenance, waste treatment and overhead in bioprocess operations. So, raw material and media for the microbial growth, for the bioreactor operations, utility and energy like water, electricity and steam, labor and maintenance. So, it includes wages for the production and maintenance workers, and waste treatment, the proper disposal of any byproduct or the waste generated. This is very important to comply with regulations as well as sustainability. So, now you can summarize. Let us say if you have any idea for bioengineering, So, you see there are two. First you start with the capital investment and second is the operating cost. So, you had this process flow diagram. So, there you are going for the equipment, then purchase equipment, then these part consider this capital cost, and parallelly depending what is the conversion and yield to the raw material, utility, labor and consumables, these comes under the operating cost. And these whole thing, it depends what is the volume or mass of the product. In addition, as we are all focusing on the economics part, so the process efficiency, as we have discussed earlier also, it plays a very crucial role, particularly the conversion efficiency, that how efficiently the subject is converted to desired product. There should be typically, ideally there should not be any residual substrate. It should ensure 100% utilization. Then product yield, the product yield indicate the how much product obtained, let us say Y P by S. So, you have to maximize the product yield, and productivity rate, that rate of production, product formation over time. So, that need to be improved, and process optimization. So, this is coming through the continuous monitoring and optimization of process to ensure high efficiency and scalability in the bioprocessing. So, parallelly to this economic analysis, the process efficiency part should also be considered, and the necessary steps should be taken to improve the process efficiency as well. Now, what are the matrices which we consider for the economic evaluation? First is cost of goods sold. It includes all cost of producing a product unit such as raw material, labor and overheads. Then another term comes net present value. So, NPV calculates the present value of future cash flow to assess long term project profitability and financial returns. So, basically it calculates the difference between the present value of cash inflow and the present value of cash outflow over time. Next term is internal rate of return. So, internal rate of return indicates the discount rates where NPV equals 0, the revealing the project's profitability threshold. So, in other way we can say average yearly profit rate from the bioprocess plant that indicates the satisfactory return compared to the other investment, because at the end the profit should be made from a business or investment. This is very important parameter, payback period. Payback period measures the time needed to recover the initial investment. It highlights the risks and liquidity aspects. So, typically if this is shorter payback period, means it indicate the quick recovery of investment and project is less risky, and if it is a longer payback period, means there is a more risk involved. Now, we want to see how to understand the profit part. So, there are two terms, gross profit and net profit. Gross profit means what is the annual revenue minus annual operating cost, but when you go for the net, then it will be gross profit minus there are some taxes and plus depreciations. So, depreciation is a non-cash part, but still this is considered. So, one can consider what will be the gross margin. It should be gross profit divided by the revenue, that is the gross margin. Now, coming back to the how to calculate payback period. So, we have to understand what is the total investment divided by net profit. Net profit means average annual cash flow. So, we may not consider the non-cash part here, or you can say in place of total investment, you can also consider for a given case initial investment divided by this annual cash flow or the net profit. And another calculation is this return on the investment. So, it measures particularly profitability by compare the net profit with the initial investment amount. So, it is the ratio of net profit divided by total investment. Further, the cost of good, it includes the direct cost attributed for the production of a specified quantity of product. It may include raw material, direct labor or direct overheads. So, here no indirect cost such as sales and administration is considered. So, cost of good per unit is defined as total direct production cost divided by how many number of units being produced. And one more important term is there, that is the minimum selling price. It says lowest price of final product to cover all production costs, and it determines the commercial viability of the bioprocess and calculated by adding up all the cost involved. And there is a term that is called break even point, means the total revenue is equals to the total cost. So, here I have included one example to quickly revisit this concept. So, it says a biotechnology firm plans to set up a microbial fermentation plant for producing a commercial biosurfactant. The initial capital investment required for the equipment installation commissioning is 50 lakh INR. The estimated annual net cash flow from the commercial production are as follows. So, year 1 to 10, it says what is the net cash flow. It keeps varying from, let us say, 4.5 to 8 lakhs per year. Now, we have to calculate the payback period. So, how do we calculate the payback period? Payback period is calculated that initial investment upon annual cash flow, or you can say investment upon the net profit. So, what we are going to do, we are just going to calculate the net cash flow till we reach this 50 lakh number. So, let us consider up to 7th year, 1, 2, 3, 4, 5, 6, 7, we are reaching to 48.8. It means 7 years will be there and some more time will be required. So, what will be the mode? Will be the mode cash flow required, 50 minus 48.8, 1.2 lakh mode will be required, and for 1.2 lakhs we have to go to year 8. This net cash flow is 7 lakh. So, you can divide 1.2 upon 7 means 0.1714 years. The total payback period will be now 7 plus 0.1714 equals to 7.2 years. Now, the same problem can be approached in a different way. So, as we know, the payback period is the total investment divided by the net profit. What is the total investment? It was a 50 lakh, and the net profit you can take the average for all 10 years. The average is coming out to be 7.03 lakhs per year, and again you will get 7.11 years. So, on the last slide you got 7.2 years, here you are getting 7.11 years. Further, one can calculate the rate of return on investment. Now, for here you need to calculate the net profit divided by the total investment. The total investment is 50 lakh, and what will be the net profit? For the net profit, what is the total net profit? For 10 years 70 lakhs, how much you have invested? 50. So, net profit is coming out to be 20 lakhs, and if you calculate per year, it will be 20 divided by 10, it will be close to 2 lakhs, 2.03 lakhs per annum. So, rate of return will be 2.03 divided by total investment 50 lakhs into 100, and you will get 4%. So, these are the simple calculation we consider for the payback period and rate return on the investment. Now, there is another example. It says due to increased demand, the management of a beverage company is considering to purchase a new equipment to increase the production of and revenue. The useful life of equipment is 10 years, and the company, the maximum desired payback period is 4 years. So, company expect that this should get return in the 4 years. The inflow and outflow of cash associated with the new equipment is this. The initial cost of the equipment is 37500, and these are the annual cash flow for the sales, cost of ingredient, salary, maintenance, depreciations. The Sud Beverage company purchased the new equipment. So, you have to calculate the payback period, then you have to compare with the what is the desired payback period expected, 4 years. So, to calculate the payback period, you need to have the first what is the net profit. So, the net profit will be from the sales they are getting 75,000 minus cost of ingredient 55,000 minus salary 13,500 minus maintenance 1,500. So, you will be getting 15,000. Now, the payback period will be what is the initial investment 37,500 divided by the net profit is 15,000. So, you will getting 2.5 years, and as you are getting this 2.5 years, it means it is very much possible to meet the expectation of company, and the company should go ahead with the purchasing this new equipment. So, here this depreciation is not considered because this is a non-cash item. Now, going ahead, there is a different models we call bioprocess economic models to understand the bioprocess and perform its economic analysis. So, it systematically there is computational and mathematical framework, and this is used for the estimation, analysis and prediction of economic performance of a bioprocess, and it helps in decision making about the process design, scale up and commercialization, and it quantifies the cost, revenue and profitability. So, further there are various tools are there like super flow designers. So, design for batch and continuous bioprocess. It enables the user to create detailed process flow diagram, model the unit operation and simulate material and energy balance. And further it helps in optimizing the process configuration, its scaling up and down, analysis of bottlenecks and assess the environmental impacts. Another software or another tool is Aspen Plus. This is powerful tool for modeling, simulation and optimization, and it provides the thermodynamic models and reaction kinetics. So, there is a Aspen Plus economic analyzer with estimates capex, opex and life cycle assessment. Capex means capital expenditure, operating expenditure and life cycle assessment, and it simulate the pilots and commercial scale process and perform the sensitivity analysis. In addition to that, the simple one can use the Microsoft Excel. So, there you have to entry the process data into cells and perform the calculation to generate the output. So, and it is better it is used in combination with other process simulator like SuperPro designers. So, it helps in the rapid comparison of process alternatives. So, there are different tools are there for the bioprocess economic models, and so what does it include? So, it includes the raw materials. So, it may be substrate, nutrients, chemicals. So, cost of raw material. In addition, the consumables, what are the item consumed during the process. It may be during the upstream and downstream both. For example, in the filtration, chromatography, membrane and single use bags. Utility for the electricity, water, steam and compressed air. Labor, the manpower part, and capital between bioreactor, sterilization unit, centrifuge, filtration unit, supporting infrastructure, and other operational requirement. Now, what are the process parameter and design? So, it performs the process flow diagram. So, you will get the schematic representation of overall unit operation and flow of material. So, it helps in visualizing the overall process and allotment of cost for the each step. So, in this way, even without the physical process, one can see in software and understand and further perform different analysis, for example, mass and energy balance. So, this mathematical expression to determine the quantity of input and output, and further this is very important for the environmental impact assessment. So, one can calculate the yield, what should be the concentration and what is the productivity. In addition to process flow diagram and mass and energy balance, it goes for the economic calculation as well, like capital expenditure. So, it includes this funds in acquiring and upgrading the physical assets, equipments, buildings and essential technologies, and operating expenditure, raw material, utility, labor, maintenance, waste management. And this is very much crucial for the life cycle assessment and techno-economic analysis. And interplay between this capital expenditure and operating expenditure is determine the sustainability of bioprocess development. So, this we have already discussed the cost of good. So, it is total direct production cost divided by the number of unit produced, and you just see this capex includes the capital investment, this is the operating investment. So, it directly influence the profitability and sustainability, and COG measures the process efficiency and competitiveness, and it guides the optimization, pricing and the strategic decisions. Now, what is techno-economic analysis? We will not go into detail, but briefly we can see this integrate this process engineering and financial modeling. So, it evaluate the commercial feasibility of a bioprocess. It may be the existing bioprocess or it may be a new technology or new process altogether. So, it guides the investment, research and development and scaling up decisions. So, significance, it identifies the economic bottlenecks, determine the minimum viable product size, it avoids the costly investment and support the funding or the partnership decisions. So, what are the steps? Techno-economic analysis is first use selection and establishment of process, then go for process flow diagram, material energy balance, estimation of expenditure, then finally go for financial analysis and sensitivity and scenario analysis. So, for example, you just see production of biofuel from lignocellulosic biomass. So, these are the inputs and development stage and the assessment stage. So, input you may have equipment, installation, energy, feedstock, chemicals, financing, manpower. In development you just see optimization as well as the innovation part. So, there it includes the pre-treatment, then fermentation, then downstream processing, and finally these are your product between biofuel, enzymes, chemical precursor, additives, protein and energy. So, there you have to see what is the competitive process, revenue and transportation. There you have to perform the assess, so inputs, development and the assessment. In addition, this environmental impact assessment is very important because particularly to meet the regulatory requirement for the any industry including the pharma industry. So, the whole objective is to minimize the waste generation, and whatever waste is there that should be properly treated, disposed, or if possible it should be reused to achieve the zero discharge. Then further, while considering this economics analysis, one should also consider the sustainability part. So, we will in next few slides we will just see the sustainable bioprocessing. So, we need to have the sustainable process which should not harm the environment as well as this should be not very energy intensive process. The possible solution is to analyze the waste generation and conversion of resources and energy. The possible area for improvement to save energy, save water, minimize the use of material, minimize greenhouse emission, minimize the effluent generation and minimize the environmental impact of the effluent. So, you may have the solid and liquid effluent, or you may have the gas effluent. So, solid it may be your cells, liquid it may be the spent broth or maybe buffer or solvent. Emissions U2 will be there, but there will be other organic gases or it may be the other volatile compounds. So, particularly there is a large quantity of water and is used in the bioprocess, because typically if you consider there is a yield titer of 10%, 20%, it means 90 to 80% is the spent broth that need to be properly treated and discharged. So, one can consider the waste matrix. So, this matrix compare the across different manufacturing sector and product to measure their relative environment impact. So, one option is to calculate the E factor. The E factor is defined as mass of waste divided by the mass of product. So, if there is a higher value of E factor, means there is a more waste generation and negative impact on the environment, and ideal E factor it should be 0, and here it does not include water. Another parameter is the mass intensity. So, it is alternative index for the waste generation, and ideal value of mass intensity is 1. It is defined as mass of raw material divided by mass of product. So, if all the raw materials are converted, so you will get the ideal value as a 1. There is another parameter, it says environmental quotient. So, environmental quotient is E factor into Q. So, it says quantify both relative amount and type of waste produced and magnitude Q in both volume and location dependent. So, for example, here Q reflect the extent to which waste represent and the environmental problem. So, there should be certain factor or certain value for the Q. So, that is the environmental quotient, and another term is the effective mass yield. So, it says mass of product divided by mass of non-benign raw material. So, it says non-benign raw material means water, dilute salt, dilute ethanol, acetic acid and so on. So, this is alternative to represent the environmental impact of the waste. So, it says effective mass yield. So, for example, if we just see here in the a bioprocess engineer is analyzing a fermentation process that produces 120 kg of desired product. During the process 180 kg of solid biomass, aqueous solvent waste excluding water of 60 kg and waste water of 1200 kg is released, and from the biomass generated an untreated substrate stream of 40 kg is recovered, purified and recycled back. They calculate the E factor. So, how we define the E factor? E factor is defined as mass of waste divided by mass of product. What is the mass of product? Mass of product is 120 kg. Now, what is the mass of waste? Mass of waste, you are generating 180 kg of the solid waste, and from 180 kg and you are generating the aqueous solvent as 60 kg plus 60 kg, and from the biomass generated an untreated substrate stream of 40 kg is recycled, minus 40 kg is further recycled from this biomass. So, total the waste generation will be 180 plus 60 minus 40. So, it will be 200 divided by the mass of product 120, so you are getting 1.67, and this value is greater than 1, it means it will have negative environmental impact. So, in this way we can consider this sustainability along with economic analysis. Further, I have prepared a few slides where you can see how these models are used to design and perform the economic analysis. So, insulin is a protein, and nowadays it is being produced by the fermentation. So, use the recombinant E. coli or the recombinant yeast. So, it has 51 amino acids, A chain and B chain, and total molecular weight is 5.8 kg. So, in the bioprocess we go with, you'll end up with this proinsulin is produced, then proinsulin is further subjected to enzymatic conversion to get the insulin, then it goes for the purification, and then we finally get the recombinant human insulin. So, one example is here, let us say super pro is used, and these are the input parameters. Let us say global demand was 50,000 kg, demand was growing at a rate of 20%, plant size here to produce 1800 per kg, total number of batches per year 160, and fermentation broth volume or per batch is 37.5 meter cube, and process, it includes the fermentation, primary recovery, reaction, and the final purification step. So, this software this designs or predicts the entire flow diagram, the first step. Now, from this flow diagram you can further identify based on different color. So, you just see the blue one is the fermentation part from here to here, then primary recovery part followed by the reaction part. So, there you are getting from proinsulin to insulin, then you finally go for the final purification part. So, in this way that you are able to generate the entire flow sheet, and along with those flow sheet you can also perform the economic analysis. So, I have summarized here. So, it says it will have 27% raw material cost and 31.9% the consumable cost. In addition, the facility development cost 24%, waste disposal 7.3%, utility 0.2%, and labor 7.3%. And further, if you see the breakup of operating cost associated with each flow sheet sections, in the flow sheet we had 4 different sections. In the reaction, it requires 61.3%, the maximum amount of MSO amount is required there. Then final purification, or you can say downstream, is again costly process, but in fermentation you see there was media cost and other thing, it accounts only 7.3% or 8% of the total cost. So, if you consider this 8% also, so you just see 8% is coming for the upstream, and then 92% is accounting from the downstream processing. So, in this way you can analyze and understand the bioprocess. So, there are certain challenges in the bioprocess economics, this availability of raw material, stringent regulatory requirement, high capital and operating cost, technical bottleneck, and process complexity. Further, this data management and model standardization. How do you understand those, how many risks are there in the predicted model, whether those model have been successfully tested or not. Then pressure from the market and competitor. So, that is very important, because once you are going for a new process or new product, so there may be already competitors, and in addition there may be market fluctuations or product failure. Plus, this is very important, this if the demand forecasting was inaccurate, then you have to be careful. Further, the environmental factor, as I told, along with the economics or the profitability, the sustainability is the equally important, because environment need to be preserved. So for that, temperature, humidity, this energy requirement, waste generation, those things need to be considered. Further, so once there are challenges, so there are a lot of opportunity for the innovation. So one can go for this redesigning the process and equipment to maximize the productivity, process intensification. Then if you are working with the batch, one can try to shifting towards the continuous process to reduce the production time and improve the product consistency, and use the single technology. So this eliminates the need of cleaning and sterilization and reduces the downtime. Further, metabolic engineering and strain development, lot of work is going on to get recombinant strain, and further you engineer in such a way that you can maximize a particular flux. So with the recent development, now you name any metabolites, it is possible to produce via bioprocessing. Then we say sustainable and green bioprocessing. So we should try to shift towards this renewable bioresources, like one can go with substrate which are natural resources, or they are waste or byproduct from the other process, for example glycerol. Then process analytical technology. So there you have to go for the real time monitoring for optimum conditions, and once you are going for monitoring, we have already discussed, then you should be able to control, and once you are able to go for good monitoring and control, then you can improve the yield, you can reduce the variation and minimize the waste generation. So this control is equally important, and there are a lot of scope. So with this I will stop here. So today we discuss about what is the bioprocess economics, what are the different component of it, and how you evaluate, particularly in terms of payback period and return on the investment. Then further we discuss what are different modeling options available for such cases, and after discussing those modeling options, one need to consider this sustainability part. So we discuss sustainable bioprocessing, and finally we concluded what are the challenges and opportunity. Thank you so much.